Dear students, now we will discuss about the work done by variable force. Here the variable force means the force which is not constant over the interval of time, rather it varies at every instant of the time. Sometime at some instant of time, if it has the larger magnitude than at some other instant of time, it will be smaller in the magnitude. So the force is variable over the interval of time. Now we will discuss how we can analyze the work done by variable force. Now let's suppose we have a body of any mass and like this one, and we displace this body from position xi to another position xf, and here we are applying the variable force. So the force acting on it is the variable force, which is not constant over this interval from xi to sf. If we plot a graph between x component of the force and x-axis, so this one is the x-axis and this is the x component of force. If we plot a graph, it will be like this one. Now if we divide the distance from xi to xf over a small displacement delta x, like this one, we can divide the whole distance into small displacements delta x. Okay, if now this small displacement can be represented by delta x, now we can consider that the x component of force is constant over this interval of delta x, over interval, small interval delta x. So we can find the work for this small interval delta x, and this will be the shaded region. So the small work done over this displacement delta x, it will be equal to delta w is equal to fx delta x, that is small component of displacement, and this will be equal to delta A. Now what is the delta A? Delta A is the area of shaded region under the curve. So this is the area of shaded region. So the force F component of force, we consider it approximately constant over the small interval. Now what will be the total work done? Now the total work from xi to xf. The total work done, for the total work done, we can sum up all small displacements. So the work done will be equal to summation xi to xf into fx delta x. So this one is the total work done from xi to xf. Now what happened if delta x approaches 0? Delta x approaches 0 here means that if delta x is very small, that is very small, and it's like that it's approaches 0, then there will be infinite numbers of displacements without limits. We can say that there will be the infinite numbers of small displacements. So although the number of terms in the sum increases. Now the number of terms in the sum will increase, but the value of the sum will approach some definite value. So we can write it. So we can write the definite integral from as the limit x approaches 0, like limit delta x approaches 0, then summation from xi to xf into x component of force into delta x. This will approach a definite integral from xi to xf into x. So this will be the, we can say, no, this is the work done. So definite integral is equal to the area under the curve from xi to xf. This is equal to area under the curve from xi to xf. So the work done can be written as like w is equal to from xi to fx into fx delta dx. If fx is equal to f cos of theta, which is the x component of force, is constant. What happened now? If it is the constant, then the work done will be equal to f dot d. Now if we consider, if more than one forces, if the more forces are acting on the body, if more than one forces acting on the body, then the work done will be equal to the work done by all forces, all resultant of all forces, and you can write it like the summation of work done, and this will be equal to the net work done by all forces, and we can write it from summation xi to xf into sum of fx, that is the sum of all forces, into dx. So this will be the work done by all forces from xi to xf. Thanks for watching. For more videos, please subscribe our channel.